Well, welcome everybody. My name is Warwick Rudd and welcome to the first DBA Fundamentals Down Under for 2017. For this first session in January, we've got Parikshit from the SQL Tiger team talking to us about how SQL Server 2016 SP1 changes the game. Now I'll hand over to Parikshit just before, in a couple of minutes time, but before I do, we'll just run through some housekeeping. And first off, we just want to say a big thank you and a big call out to our sponsor, SentryOne. Without SentryOne, it makes it difficult for us to put on these sessions for you. So make sure that you go along to their website, have a look at the downloads and articles and demos that they do have available. There's a lot of content there, so make sure you go and visit the sponsor and enjoy the wonderful products that they do provide for us. Now, this session is being recorded and will be available on the archive site on the DBA Fundamentals in a couple of days' time once the session has been completed for you to come back and review this session at any point in time. Make sure that you stay involved with PART. If you haven't signed up already to any of the other virtual chapters where you can learn about lots of different parts of SQL Server, it's well worth your while signing up now and keeping abreast of what is happening in the environment. So without wasting any more time, I'll hand over and we'll start this presentation.
Thanks, Warwick. All right, let me start sharing my screen.
The broadcast is now starting. All attendees are in listen-only mode.
Hey, Warwick, can you confirm if you are able to view my screen?
Yes, I can see the first slide of your slide deck.
All right, great. Thanks a lot. Thank you, folks. Thanks for joining in. I really appreciate you spending your time, and I'll try to provide content which might be of interest to you and which will help you understand some of the improvements which we have shipped in the latest release of SQL Server, which is SQL Server 2016 Service Pack 1. So before I move on, a quick introduction, quick introduction about me. My name is Parikshit, or you can call me Parik. I'm a senior program manager with the SQL Server Tiger team in my current role. It has been 9 years for me working with Microsoft and with SQL Server. I've also authored a couple of books on SQL Server, one of which is SQL on Azure, and one is on SSAS Tabular model, both of which are published by Syncfusion publication. And I'm an avid blogger, and you might see all our blog posts in our team blogs, which is the SQL Server Tiger team blog and our releases blog post, as we push all the blogs for all the releases in our releases blog post. So yeah, you have our Twitter handle and the Tiger team Twitter handle in case you're not following us. I mean, we're pretty active on Twitter. If you want to be up to date on the latest releases and news about SQL Server, I think you should definitely consider following our Twitter handle. So moving quickly, the agenda for this particular session. I think this is a good time for me to deliver this session, and also a good time for me to wish you all a very happy new year. So 2016 has been a remarkable year for SQL Server. So I think I would want to start with a review of all the announcements which we have made and share some of our plans and some of the story behind what decisions were made and why they were made. I think that's the key point which I want to drive from this message. Consistent programming, programmability surface area, that's the change which we introduced. That's a big change which we introduced in SQL Server 2016. Other scale diagnostic improvements, understanding how SQL memory allocation works, which becomes important now that we have uplifted some of the limits and introduced some of the new features in lower SKUs additions in SQL Server 2016 SP1. What are the differentiators in Enterprise Edition, known issues, and some of the other supportability and diagnostic improvements which we have done in 2016 SP1. Now, the chances are I may not be able to cover everything because we have added bunch of improvements, and if I were to go through them in detail, I might need more time. So in the end, I might skip few slides providing all the resources, but if time permits, I definitely want to cover them. That's the reason I have it in the slides. But if I'm not able to cover them, I'll apologize. But you will find all the details in the resources section and all the blog posts which are relevant to SQL 2016 SP1. Okay, so let's start with the good news and what a way to end 2016. SQL Server announced as a DBMS of the year, and that is coming from DB Engine. If you're not familiar with DB Engine, it ranks all the database engines, which is SQL, RDBM, and NoSQL, open source commercial license, wherein it ranks the databases based on the popular trends in the internet, Google Trends, job postings, questions on the forums and posts, and this is where Microsoft SQL Server came out as a clear winner. We also got featured in a Wired magazine after this announcement, which was done by an independent Austrian consulting company, wherein they also analyzed and found that Microsoft SQL Server's popularity grew much faster than other database engines. So lot of good news coming around for SQL Server, the popularity growing. So we must be doing something right. So I wanted to kind of quickly review on some of the plans or some of the announcements which we have made, and some of the story behind or the reason behind our announcements, which might give you some insights about the growing popularity, adoption, and prospects for Microsoft SQL Server. So in March 2016, Scott Guthrie, who is our enterprise VP for cloud and enterprise, made an announcement that we'll be bringing SQL Server on Linux. The intention was to give customers the choice of their platform, whether it be Windows or Linux or cloud. We wanted to provide a consistent data platform and which can be deployed on the platform of the choice for customers. So that is the key message which Scott had, which came out from this particular announcement, which is where we started our journey for SQL Server on Linux. Then we released SQL Server 2016, and I think I don't need to say anything else. I mean, and if you're still not following SQL Server, and if you're still interested to know why it runs faster, I would highly recommend you watch through Bob Ward's video on SQL Server and Bob Doer's blog series on SQL Server runs faster. Out of the box improvement, some of the features which we have introduced, like dynamic partition management object, dynamic PMO, Autosoft NUMA, DBCC check DB, which scales with the new algorithm of multi-scanner, Columnstore unblocking some of the features, like allowing a clustered index and a non-clustered index together with Columnstore. So we made a bunch of enhancements with SQL Server 2016. Then came SQL Server 2014 SP2. So this is where we backported some of the improvements which were possible maintaining the existing design, and this is where we backported some of the improvements which I can think about is Autosoft NUMA, dynamic PMO, sub-latch, super latch enhancements. I don't know if you have applied SP2, but if you have not, and if you have 2014 instance, you might see some performance difference out of the box after applying SP2. So, which is also a testament of our commitment of investing in the in-market releases of SQL Server. Then came SQL Server 2016 SP1, which we released in November, where one of the biggest thing is consistent programmability interface, and this is where this is what we're going to talk about next. So I don't want to cover or go detail into that. And then we recently announced and have SQL Server vNext CTP1 available for download. And again, you will have consistent experience, consistent SQL Server experience, consistent tooling experience, and now the consistent programmability platform on the platform of your choice, which is Windows, Linux, Azure, containers. And when you're moving from SQL Server on Windows to SQL Server on Linux, we wanted to provide you with the same consistent experience, so you don't have to revamp your skills, you don't have to retune your application, you don't have to make much changes when you're moving across platforms. So that's the key message, and that's one of the reasons and one of the change in the culture which has brought to the popularity and which has added to the popularity of the SQL Server. So what is SQL Server consistent programmability surface area? What do we mean by that? So I wanted to start with addressing some of the challenges which we heard from customers when we were talking with customers and developers. All the ISVs developers were pretty much very excited with the SQL Server 2016 release. They saw the improvement in the code. But one of the challenges they had was that if we have a developer who is developing an application, and let's say he's developing an application for a small business, which is currently using Express, which free edition, which is an entry point for SQL Server. They're a small business. They don't have that much data, or they don't have their mission critical application running there. They want to start with Express edition. Now, if they want to grow, and if their business grows, where they want to add more data volume, they want to go to standard edition of SQL Server, and the application cannot just lift and shift and migrate. There is a lot of effort which goes in for an application to revamp and adopt to the latest features of standard edition. And now some of the greatest features, some of our latest features like Columnstore index, in-memory OLTP, row-level security, dynamic data masking, which we have introduced, the developers cannot leverage unless they have their customers who is using enterprise edition of SQL Server. So the absence of these features or the inconsistent programmability area, surface area, was the main challenge. A developer has to maintain different code bases, and that was one of the trigger points for us to decide that, hey, you know what, we need to provide a consistent programmability surface area for everyone, and the only differentiators across all the edition should be performance, scale, and availability. Those are the only differentiators which we want to achieve, which we want to have for our customers. So a business of any size can adopt SQL Server, and an application or an ISV can build intelligent application which can work on any SKU of SQL Server. So that was the whole idea and intent of consistent programmability surface area. And I want to give an example which we commonly use. I know you might not be a Starbucks fan, but because if you're in Australia or India or somewhere in Asia, Australia, by the way, I have great local cafes. So but yeah, in US, Starbucks, and I'm in Seattle. So if I were to draw an analogy here, you want to have the same coffee, whether you ask for a tall, medium, or a large glass. The only differentiators are the scale here, but we won't say that, hey, for a small glass, we won't add sugar for you, or we'll serve you coffee at a normal temperature, or so on. So we wanted to drive a message wherein, hey, you know what, we wanted to provide a very consistent programmability surface area for our customers. So these were the design goals which we had in mind when we were looking to provide this enhancements for customers with SP1. So some of the programmability features like in-memory OLTP, Columnstore, row-level security, dynamic data masking, and always encrypted are lighted up now in all the lower SKUs. So if you're using Express Edition, you can use in-memory OLTP, Columnstore. You can, in fact, optimize your application to use Columnstore compression and achieve better performance and results even with Express Edition. The only differentiators which are there for Enterprise Edition is now performance, scale, availability, and operational features. There are differences in the always-on operational availability groups, scale limits, and virtualization rights. Those are the core differences in the Enterprise Edition. And whereas the programmability features are now same or flattened across all SKUs. So how does the picture look like after post SP1? So with SP1, which to be more precise, with SQL Server 2016 SP1, you would see all the features on the right-hand side with green, which are lighted up. Now, even if you're not adopting or if you have not yet adopted some of the latest features, if you want to leverage something like database snapshot, if you're a DBA and if you want to, as you know, that when you run DBCC check DB, it takes an internal snapshot, and the internal snapshot requires a space in the same drive. So if you do not have the same amount of space, then you might want to create a snapshot and run DBCC check DB on that snapshot on a separate drive, and that's how you can work around things. So now, if you're on a lower SKU, you can leverage some of these features and adapt to it. So these are some of the features. The ones which are in white are not possible because of the absence of SQL Server agent, or if file stream which is not supported, multiple file stream which is not supported on local DB. Those were the features which we couldn't light up, but otherwise we pretty much flattened all the programmability surface area. So moving on, and in fact, let me take a pause here, and Wadvik, if there are any questions for me, let me poll and ask if there are any questions at this point.
Not at this point.
All right, great, sounds good. So now, what are the new limits starting SQL Server 2016 SP1 across these editions? So honestly speaking, we haven't changed any limits. If you go back and look at the edition comparison charts, the limits are pretty much the same. However, having said that, when we were lighting up new features like Columnstore in-memory OLTP, we also were cognizant of the fact that for customers to be able to adopt to these latest features, we cannot compromise on their existing memory or CPU usage. We want to make sure we give them extra just so that you don't feel starved for reusing or leveraging some of the new features. So the existing scale limits holds true. There's no change in that. However, we have also, when we were working on this, we realized there was our documentation was not accurately reflecting our limits. So we made changes in the documentation, which is the ones which I have striked there. Previously, we said it was max memory utilized per instance, but it is essentially max buffer pool size per instance, and I'm going to explain that in detail in the following slide. But otherwise, the scale limits, if you look at the CPU memory, those limits remains unchanged. We have added limits for lower SKU for the Columnstore and the in-memory cache. For Columnstore, our limits for standard edition is 32 GB, which means if you're using a Columnstore, and this is an instance-wide limit. We're going to talk about that as well. And for in-memory data, if you're using in-memory memory optimized tables for your databases, you can have an 32 GB of limit per database. That's not per instance, but it's per database for standard edition. So let's first go to and understand how does the memory works in SQL Server. What is the changes which we have made, and then understand more about the new documentation or more clarifications which we have made starting SQL Server 2016 SP1. So before SQL Server 2012, this is how the SQL Server memory was managed. When SQL Server starts up and as data and index pages are populated, SQL Server would reserve buffer pool memory in VAS. I'm using the term reserve, and it is reserved in VAS. What that means is when you start up SQL Server, you won't see your RAM utilization going up immediately. What you will see is every process within SQL Server gets something called as a virtual address space, and when SQL Server starts up, it starts reserving the memory in your VAS. Now, all that memory is reserved for SQL Server buffer pool. Now, buffer pool primarily is the cache for data and index pages, which is of 8K size, and therefore your SQL Server buffers are also of 8K in size. And that's the reason if there is any consumer within SQL Server which requires memory which is less than or equal to 8K in size, that will go to buffer pool and ask for memory. And these memories is what we used to call it as stolen memory. If you are familiar with the older versions of SQL Server, this was a common term which is still in use. If you look at our performance counters, you might see traces of this, but stolen memory is basically memory from buffer pool which is not used for data and index pages. Why it's called stolen? Because other components within SQL Server also needs memory, and if needs memory less than equal to 8K, we would go to buffer pool and ask for memory and reuse the same memory. We will not, we never used to allocate memory outside buffer pool. However, if there is a requirement of memory which is more than 8K in size, which is what we used to call it as multi-page allocation, or if there is CLR integration wherein if the CLR code requires memory, or if there is a thread, if the thread stack which would normally need memory for stack, those memory were allocated outside your SQL Server buffer pool. And one of the other things to keep in mind, your max server memory configuration in SP configure was only meant to limit your buffer pool. It was not limiting your non-buffer pool allocation. And that is the reason when even if you're on SQL Server version less than 2012, if you're on 2008 R2, you might see that you might have set your max server on a 32 GB physical RAM server. If you have set your max server memory, what kind of workload you're running, if there is a heavy usage of multi-page allocation, and the typical consumers of memory are plan cache or query execution engine, which needs to allocate memory when they are sorting and hashing. So this memory would come outside buffer pool if the requirement is more than 8K. So this is supposed to be a non-B-full region, but this is before SQL Server 2012. Now you need to understand what changed, and which is very relevant to our discussion, which applies to 2016 SP1 as well. So starting SQL Server 2012 and higher, we made changes in the way we allocate memory. We still have SQL Server buffer pool, which is the cache for data and index pages, which is meant for 8K pages. But buffer pool is no longer will go ahead and reserve space for others. It will not be a donor of memory. Nobody would be stealing memory from buffer pool. Every SQL Server component will have its own dedicated cache, and that cache, like plan cache, for example, procedure plans and ad hoc query plans, will have its own dedicated cache. You will have CLR memory, which will have its own dedicated cache. You will have other components which can have memory requirement, which will take away memory from the cache. You have log pool. You have Columnstore index, which is introduced starting SQL Server 2012. You have in-memory OLTP cache, and for every database you will further continue to have more in-memory OLTP cache. And now one of the big changes, your max server memory limits. So I'll just take a step back. You will no longer have something called as single page allocation or multi-page allocation. We have a new allocation mechanism where we no longer restrict it to a single page or a multi-page. We have any page allocation wherein it could be of any size. For buffer pool, because the pages are still of 8K in size, the allocation is 8K in size. If for other memory components which still honors this, we would still have multiples of 8K in size. For example, for plan caches, for some of the huge plan caches, we still have allocations which are multiples of 8K. But we also have components like Columnstore and in-memory OLTP, which can be any allocation which is required by that particular consumer or memory object. And that is allocated from that particular cache, and it will honor the max server memory. And that's the reason, if you previously had SQL Server before 2012, if you had your max server memory to 24 GB, but SQL Server was using 26 GB, now if you're capping your max server memory to 24 GB, SQL Server will try to manage and be within that 24 GB. And within that 24 GB, it will have buffer pool cache, it will have Columnstore cache, it will have in-memory cache. But now if you can afford to have more RAM, and if you're limiting your max server memory, you might see a starvation and a lot of I/O, which might impact the performance of SQL Server because of the excessive paging or the excessive memory pressure which the SQL Server might be suffering from. So the only memory component which can still be allocated outside max server memory in SQL Server starting 2012 is direct allocation. When I say direct allocations, is any external DLL which is loaded in SQL Server memory and which is not allocating memory through SQL Server. To give you an example, if you're running Oracle Link Server, and if you have Oracle driver loaded in SQL address space, and if it's allocating memory, then SQL Server, if you use perfmon counter, it will still show up in SQL Server under SQL Server process private bytes. But SQL Server, it's not coming through SQL Server. It's a direct allocation which is bypassing SQL Server and directly calling our Windows Virtual Alloc API. So that's the key difference, or that's the memory allocation which SQL Server do not track. The another memory allocations which is thread stacks, as worker threads spin up in SQL Server, the thread stacks are not allocated or accounted by SQL Server memory because it's more of a, it directly calls the Windows APIs, so it is not accounted by SQL Server memory. But thread stacks are also, I think it has like 2 MB allocation per thread. So if you are having 512 threads running, you might see somewhere around 1 GB of allocation. So it's proportional to how much, how many worker threads are active at a given point in time, which are running, and that might be allocating memory. But I would say it is pretty small. Normally, it shouldn't go beyond 1 GB. So if there is any third-party DLL which is allocating memory, that might be the reason of memory exceeding max server memory starting SQL Server 2012. So now, keeping this keeping or understanding the new memory allocation starting SQL Server 2012, I just want to show you the next slide again, and just emphasize on the documentation changes which we have done. And let me use a highlighter here. So we are talking about max server memory is the buffer pool size per instance. So 128 GB is actually a buffer pool size, which means SQL Server can allocate memory, or there are other caches which needs memory outside buffer pool, and that can still be allocated outside a buffer pool. So you can actually have a 256 GB RAM machine with SQL Server deployed on it and having a max server memory, let's say capped to 192 GB. In this case, only the buffer pool will be capped to 128 GB, but you can still have other caches using memory outside buffer pool depending upon the usage which you have. So now starting to, SP1, if you're using Columnstore index, you can have additional memory limit up to 32 GB. And if you're using in-memory OLTP, per database you can have 32 GB. So when you're planning your SQL Server, even for standard edition, you want to make sure you just don't buy your SQL Server or configure your hardware to match this limit. This is actually a buffer pool limit. Just to bring the previous slide again, this is only the buffer pool limit which we are talking about. And now we have added limits to Columnstore, which is 32 GB, and each in-memory OLTP, which is 32 GB. So you can actually have or go up to 256 GB or even more for standard edition, depending upon the usage, if you're using Columnstore, in-memory, and so on. So it is important that you understand this memory limits and how it works. So I want to take a pause here and ask for any questions or any comments which you might have.
Okay, so nothing's come through at the moment. So guys, feel free to send through any email, any questions, and we can get those answered at these breaks.
Sounds good. All right. So and I've also shared the blog links which provides all the details. In fact, all my slides have resources or references which you can refer through after the session or later on if you're watching this video. So you can go through those links which provide more details around each of these topics. So talking about in-memory OLTP, what are the limitations in the lower SKU in standard enterprise, standard express or web edition? The only limit for in-memory OLTP is we have capped the memory to 1/4 of the buffer pool memory limit. Buffer pool is the keyword here, and this limit is per database, which is also important to and good to know. So one more change which it is more of a documentation change, but it is important for you to understand. The Express edition, which we used to call it as 1 GB limit, starting 2012 we have actually increased the limit to 1.4 GB. So we have roughly added 400 more megabytes to the buffer pool itself. So the in-memory OLTP quota limits are 1/4 the buffer pool size. But again, this memory doesn't come from the buffer pool. It is outside the buffer pool, but it is 1/4 of the edition limit. So if it's 64 GB, which is if you're using web edition, then you'll get 16 GB. If you're on standard edition, 128 GB, and then you'll get 32 GB per database. That's also another important. More details on the blog post on how do you want to leverage in-memory OLTP. My colleague Yos has done a detailed blog post on this. He's the PM owner on this topic, so he's provided much more details than I have in this slide. But the key point which I want to drive is the in-memory OLTP across all the addition works as is exactly same without any issues. The only limitations are memory limits. So that's the key message which I want to drive. Talking about column store, again, column store memory limits are 1/4 of the addition memory buffer pool limits. But these limits are per instance limits. So that's one important difference. The other limits are performance differentiators across edition. So if you're using Express or Web Edition, the max drop is capped to 1. For Standard Edition, the max drop is capped to 2. And we have some enhancements which are reserved for enterprise editions of SQL Server, which can give up to 2x to 10x improvement in your query performance when you're using enterprise or developer edition of SQL Server. Some of the new improvements which we introduced for 2016, like filter predicate push down for string predicates, aggregate push down. So when we are calculating or filtering, we apply the filters at the segments and push it down at the lower level. So we don't scan a lot of data and optimize for resources. So, and that further improves the performance of the queries. SIMD support is supported by few modern processors which supports the instruction set which operates on the array of the data, and only if you have those kind of hardware, and if you're using enterprise edition, you might see a significant improvement or boost in the performance. So again, my colleague Sunil has a detailed blog post on what are the differences in column store indexes. Now I'm talking about limits, which might sound about what we are not giving, but it is important to understand what can you achieve with column store index. For instance, with column, if you compare the performance of a data warehousing kind of a query, if you have a fact table, and if you create a column store index, or if a clustered column store index on top of it in 2016, which now allows you to have primary key and other non-clustered B-tree indexes on top of it, you can achieve compression out of the box on these tables, which further improves your query performance of aggregate queries. So if you were to compare your edition, if you were to be on 2012 or 2014 standard edition, and if you migrate to SQL Server 2016 SP1 and create a clustered column store index out of the box, you will see performance improvement without making any changes in your application. I think column store is one of the biggest differentiators in 2016, wherein without making any changes in your application code, you will see dramatic difference in your query performance. So you can refer to the blog post for further details, where Sunil shows the perf difference in the query from a row store index and a column store index. So you will see the difference there. Having said that, if you were to still run the same query against an enterprise edition of SQL Server on modern hardware, you might still get significant performance benefit as well, because of some of the latest features in Columnstore. Okay, so what are okay? Talking about Polybase, Polybase is also now supported. If you're using compute nodes, I'm sorry about that. My Outlook just got restarted. I don't know why. Okay, I'm back online. Just give me a minute before. Hey, can you confirm if you're able to view my screen?
Yeah, I can see your Polybase slide.
All right, thanks a lot. Sorry about the glitch. So Polybase is the compute nodes of the Polybase can now be deployed on any SKUs, Standard, Express, Web Edition, but you still require an Enterprise Edition if you're using a head node for scale-out purpose. And again, this is purely a scale limitation, but if you're using a standalone Polybase feature, it works as is without within any edition of SQL Server. So what are the scale, perf, or operational differences in Enterprise Edition which we have? So I've listed all of the perf, scale, and perf and scale differences in Enterprise Edition, which is still our distinguished, a highly distinguished edition of SQL Server. So you will see all the core differences which is there. You can talk about, and so there are some of the availability, manageability, and security features here in Enterprise Edition which are reserved for Enterprise Edition, which provides better availability. Some of the operations like online page and file restore, online index operations, online schema change. Now, one feedback which we got, and I think we were cognizant because there were some engineering challenges, we couldn't get online index operation. So online index operation is still reserved for Enterprise Edition because we feel it is a distinguished feature which should be reserved for Enterprise Edition. However, if you're a developer and if you're using the T-SQL programmability surface area, you will still have to use a different syntax for Enterprise Edition versus Standard Edition. We are aware of the fact, and we are working on it. This is what I can say at this point in time. So you will see that change. This is the only thing, if you were to compare the T-SQL programmability, which had some engineering challenges which we couldn't ship it out in time. So, but again, it is more of the syntax which will allow you or which will allow a developer to be consistent. But online index operation by itself is still an enterprise-only operation. So before I move to the next slide, I again just want to pause here to see if there are any questions around this topic before I move on.
Okay, so we've got two questions for you. So first one,
yep.
Is there any formula to calculate the max memory in SQL Server 2014 and SQL Server 2016?
Okay, is there any formula to calculate max server memory in SQL 2014 or 2016? So I'm assuming that the question is that so ideally you should understand your workload and or you have to start somewhere and do a capacity planning and gauge how much usage you anticipate to have. This is based on your database size, the number of database you're going to have, and ideally, in a perfect world, you want your entire database to be cached in RAM to be highly performant. But you will never be able to do that because of the other constraints which you'll have. So, but if the question is on a given server, how much is the max server memory should I be setting? My rule of thumb, and again, this is purely based on my experiences, so take it with a pinch of salt. I would cap it to 80% of whatever the RAM which you have. Now, this is under the assumption that your SQL Server instance is the server is dedicated for SQL Server, and you are not using any other application which needs more memory, which can get into a memory contention with SQL Server. If I were to have two instances on the same server, then I would cap 40%, 40%, or 60-20, whichever ratio which you think is important. But formula to even gauge how much my instance would, or how much RAM would I need for my server, that's a complex equation and will need more details about what your server looks like. But hopefully that is what you were looking for, but I'm not sure if I've answered your question.
Okay. Are there any DMVs available to monitor the mem usage in in-memory OLTP?
Mem usage, is your question mem usage within in-memory OLTP or memory usage for in-memory OLTP? So let me answer it. So you can use memory clerk, sys.dmos memory clerk to track memory usage of in-memory OLTP. But beyond that, we do have some DMVs which are available for tracking in-memory OLTP. I don't have them at the top of my head, but I can follow up. I think they are available in Yoss's blog post. I think if you read through the blog post, you'll get further details on that. But yeah, I may be able to find it out later if I can follow up on that.
Okay.
If you can just drop me a message on Twitter or someone, to provide your contact details, I'll be more than happy to follow up on that.
Okay. Last question. In SQL Server 2016 SP1, does it support restoring a table without restoring the database as a whole, like some of the third-party tools do?
Not yet. If I were to do this, you would have to use a utility called BCP or export import, which is more of a logical export of a table into a file, and then you can import it. But we, out of the box backup restore, we don't support a table, which is a logical backup, if that is what you are asking. But if I were to do that, I would use BCP, which is a native utility within SQL Server, allowing you to export a table into a file, and later on you can import that same file into another database. That's how is the supported way. Or you can have SSAS. You can use link servers. I would use link servers, which are more faster, and do a select star kind of query. That is another couple of ways I can think about of importing a table from a remote SQL Server instance.
Okay, so one that's just come in as a follow-on to that question. In SQL Server 2016, does it allow me to extract one table from a backup file?
One table from a backup file? No, that's currently not supported.
Okay. We're good to continue.
All right, sounds good. All right, so talking about some of the things which we are not proud of, but it's important for you to be aware of. Some of the known issues, but something when you are deploying SQL Server 2016 SP1, you should be aware of in your environment. Uninstall. So if you have applied SQL Server SP1 on some of the lower SKUs, and if you have also started leveraging some of the new features which are lighted up with SQL 2016 SP1, you would see that if you try to uninstall, your uninstall would work, but your database after uninstall can either go into suspect mode, it can get corrupt. To give you an example, if you have partition table, if you applied SP1 on a standard edition or express edition, created a partition table, and now if you decide to uninstall SP1, you will see your database get into that particular database gets into a suspect mode, and you'll not be able to recover it. Your options may be you restore an eval addition somewhere, apply SP1, and restore or attach the database on that server, or on the reapply SP1 on that same server where you uninstalled it. Get the database back, drop the latest feature which is lighted up, and uninstall it. So again, I don't see a reason for customers to uninstall that frequently unless there is some regression which we have not seen introduced in 2016 SP1 in the database engine especially. SQL Server reporting services, one of the the issues which we uncovered as we shipped is if you're using a secure connection, it displays a warning, or if you're using a print function, it may not work after applying SP1. For that, we have a hot fix available. There is a KB article, and I have shared the blog post which has more details on the KB article, which you need to apply if you're using SQL Server reporting services as well in your environment. SQL Server master data services. After applying SP1, if you try to edit or add a new business rule, it gets corrupt, giving you a corrupt business rule error. Again, we have a GDR hotfix patch for that, and you'll find the details of that in my blog post link here. ODBC driver 13.1. So starting SQL Server 2016. We introduced ODBC driver 13, which is compatible with some of the latest improvements and enhancements which we introduced with 2016. Later on, we also had another out-of-band release called 13.1, which started supporting Azure Active Directory integration and some of the other features with always encrypted. When you try to apply SP1, it might override. When I say it might, actually it will override, because SP1 also contains the same ODBC driver 13 which was shipped with SQL Server 2016. So if you have applied 13.1, it will overwrite back and revert it back to 13. In which case you will have to uninstall the driver installed by 2016 and download a 13.1 driver again and install it. Now this is only on the server side. If normally your drivers are on the client side, so if on the client side, if you will not be applying the SP1 server side package, so that won't be impacted. But on the server itself, and there was one bug which we fixed, which was impacting SQL Server agent in 13.1. So your agent might starting failing. So you have all the details are captured in the blog post, which you might want to refer to. But yeah, this is something which you need to be aware of when you are installing SQL Server 2016 SP1. Once again, something which we are proud of, but it is important to know. It's part of the engineering life cycle which we have. There are bugs, but these are the solutions as DBA which you need to be aware of when you're applying SP1. Okay, other improvements which we have introduced in SP1, DBCC clone database. So DBCC clone database we had first introduced in SQL Server 2014 SP2. So it was not available in 2016. In 2016 SP1 we are bringing clone database and which is further enhanced and which supports some of the latest features like query store. And one of the things with DBCC clone database, one of the design goals of why we introduced a DBCC clone database was to create a real quick, fast clone of your databases and which are schema only, which has statistics or query store information which can be quickly used for troubleshooting your queries without actually disturbing your production environment. So if you're doing any query tuning, if you find some top CPU query, you don't actually want to see the query plan, run the queries again on your production database. Having said that, you want to have the same data statistics for your optimizer to give you the same query plan, for you to tune it or tweak it to give you the best plan which works for your database. In those scenarios, clone database is your friend, which can allow you to quickly capture a clone, which is a statistics only clone. Another scenario in 2016 is query store, which is like a recorder, which you can think about capturing all the historical query plans and helping you identify any query regressions or query plan changes caused over a period of time. Now, if you have query store turned on and if you want to analyze the data captured by the query store, you don't want to hit the same database which is in production and causing an overhead. In those scenarios, you might want to create a clone database with query store information and that creates a replica of the database without the actual data. And you can then backup, restore, attach, detach it to another instances of SQL Server with the same version and use the query store reports, connect to that database to analyze the report. So that's how useful clone database can be. The design goal of the clone database was to be fast, minimally invasive, and to be consistent. The clone has to be consistent so you don't get any corrupts or suspended database. So starting 2016 SP1, we started supporting CLR objects. So if there are CLR objects in your database, it will get cloned. File stream, file table objects, in-memory tables, and query store, and which is persisted query store data. So again, it is not supported to be used in production environment. So you can't create a clone and start using your clone database and start populating a different data set in it. That is still not supported yet. So if you find an issue, you log a case with CSS, with Microsoft CSS, and you might get a reply saying we won't support your database because it's a clone database. It's not meant to be used in production. It's purely, at this point in time, it is purely used for supportability purpose and diagnostics, but not for production use. Some of the perf differences if you were to clone your, so another change which we introduced in 2016 SP1 is to an ability to create schema only clone, which was based on the popular customer feedback, which will allow you to, if you have your production instances and your dev instances and your QA server which are in isolation, and you don't want your developers to be exposed to the production data because of the sensitivity of the data, you can just create a schema only clone which doesn't even have statistics or query store information and restore it on your dev test environment and to track any schema changes or perform any changes and the way you want to use it. So for source depot is what we've heard are some of the scenarios which will be covered or are catered by schema only clones. Another thing is we have seen, or one of the main advantages of why you want to use clone is the perf difference. And a graph shows you, and this is graph which we have captured from our real world experiences with CSS and some of the large customers which we have been working with. So you see up to 60 times differences in the performance when you're using DBCC clone database. So definitely very fast and useful utility when you're troubleshooting queries. Perf enhancements in 2016 SP1 bulk inserts. So this was for one of the customers which we were working with, and they were using SAP's R3 load service, which is primarily an export-import utility, if you can think about it, supported or provided by SAP when you want to migrate your SAP workload across database platforms. So one of the challenges of this utility, it does use bulk insert when it's loading the data, but it doesn't allow you the flexibility of using tab lock. Now, one of the advantages when you're doing bulk insert with tab lock takes BU locks. The advantage of BU lock is you can have a parallel threads bulk loading. A BU lock is compatible with BU lock, but a BU lock is not compatible with any other lock. So you can think about it as an exclusive tab lock, but the parallel threads which are doing bulk inserts can actually acquire and are compatible with each other and can work on a different disjoint data sets, but the database is exclusive, the table is exclusively locked by the bulk insert. The advantages, you will see superior performance because of the minimize PFS and allocation overlay. It reduces the PFS page contention by 24 times, so which kind of brings down your data load time significantly. But if you're not able to add a tab lock hint when you're doing a bulk insert, in that scenario, if your application doesn't support it, then you're stuck. So with TraceFlag 715, we would, out of the box, within the SQL Server engine, we will turn on the tab lock for you when you're doing a bulk insert for all the tables for that particular instance. So all the bulk insert which will automatically take BU locks, and you will achieve the same performance without actually customizing your application. The only downside which you need to be aware of, if there is any queries which are either reporting queries or queries which are doing DMLs on that table at that point in time, that will be blocked. So you need to be aware of what your scenario is, but you will see if you're using SAP R3 load service itself, and if you turn on this TraceFlag, you will see significant difference in performance. So this is the graph for the customer who we are working with TraceFlag, with TD. We were able to cut down their migration time by 1/3. So 2016 RTM insert select. Okay, since we are running short on time, real quick, I'll complete this. So with 2016, we introduced parallel insert select, wherein inserts, when you're using insert select syntax, basically to copy the data tables within the SQL Server database, if you're using tab lock hint, we would, for user tables, we will make the data load in parallel. For temp table, for local temp tables, you don't need a tab lock because it is exclusively meant for that particular session. So starting 2016 RTM, we out of the box had a parallel load for temporary tables. But what we saw was, because temporary tables are temporary in nature, which has a lot of overhead on the allocation pages like PFS, GAM, SGAM, the customers started seeing, when they migrated their workload to from lower editions to 2016, they started seeing regression because of the parallel insert, and the allocation contention increased. So in 2016 SP1, we have reverted this behavior, wherein if you want parallel insert, even for the local temp table, you would need a tab lock hint. So this is more of a behavior change, so there are no surprises. If you want to see parallel insert, you would have to have a tab lock hint, but if you don't want to see that, the default behavior would be that it would not be a parallel insert. So that's one of the changes which we have done. And if you want to totally disable parallelism, which I cannot think of the reason why would you want to do that, but there is a TraceFlag 9495 which disables parallelism in insert. Maybe if you want to throttle it, if your IO is not performing, you might want to use this, but otherwise there's no reason for you to use the TraceFlag. All right, so there are other improvements, but we are running short of the time, which I don't want to cover, but I think we'll have a follow-up session by the Tiger team, and we can go in detail, and there are blog posts from my colleague Pedro and Amit, so you can also go through them. So real quick so I want to leave you with some of the thoughts. So SQL Server, one of the things starting SQL Server 2016 SP1 is it is a platform of your choice with cloud first engineering, wherein all the improvements which we ship are first lightened up in cloud, and then they are made available in vNext and so on in the box product. Consistent data platform starting vNext across Windows, Linux, cloud, and containers. Consistent programmability experience, consistent tooling experience, and we continue to invest on in-market releases as well. We are very opportunistic, which if it doesn't need any design rewrite, we would want to make sure the same improvements are also fed back into in-market releases. Like if you are on 2012, 2014, we would also want to continue investing and adding improvements in the service packs for those releases as well. So we are committed on doing that. So these are some of the resources which you should be aware of for if you want to apply 2016 SP1 in your environment. The blog post is pretty detailed, which talks about all the improvements which we shipped with SP1. For Tiger Team, I mean, we have Tiger Team GitHub toolbox, which has all some of the perf reports, BP check, Power BI reports, which can read your system health session event. So you can go explore GitHub for some of the free tools and start playing around this. We have our releases blog, which will keep you up to date on our latest releases, SQL Server trace flags, lifestyle support, and our Twitter handle. So with this, I come to an end to my session, and I'll wait for any questions which Warwick may have for me.
Okay, so it looks like, yes, we've got one come through. So can I use dynamic data masking and always encrypted at the same time?
Can you use dynamic data masking and always encrypted at the same time? Yes, you should be able to use dynamic data masking, but having said that, I want to think about the scenarios which you are targeting. So I think you don't want to expose your database to DBAs, but at the same time, through the application also you want to have you want to use some of the columns with the dynamic data masking. The answer is yes. We support feature orthogonality, so it will be supported. Yeah.
All right. Well, if nobody else has any other questions, I'd like to take this opportunity to thank Parik for coming along today and presenting in the Down Under time zone as part of the DBA Fundamentals. I'd like to thank everybody for coming along and being part of this session. This session has been recorded and will be available up on the DBA Fundamentals archive site in a couple of days' time. And as part of that, we should also be able to have the PowerPoint available for you to download as well. So if you haven't already registered, next month we have, what are we talking about? We're talking about partitioning basics. So if you haven't already signed up, make sure you sign up to hear about partitioning in next month's session, and I look forward to seeing you all then. Thank you. Have a great day.
Thanks everyone. Thanks for your time. You have a good one.